Good morning. This is video 4. Here we talk about communications protocol for data transfer into IViewOps. Now, if you're a design engineer and are just doing an engineering evaluation of a hypothetical plant, you need not set up connections for data transfer into IViewOps from an external file. You can do it like some of the other Canadian models, and you just enter it right inside IViewOps. And there'll be a video to cover that. You can look up the user manuals. Now, in video 3, we talked about using the alt spreadsheet or alt sheet in a spreadsheet to send data into IViewOps. Now, why use alt? Well, if you were, again, a design engineer, you could just use this alt sheet by itself and forget about all of this if you're not dealing with a real plant, and send data into IViewOps through the link up sheet. So this sheet connects to this, and IViewOps connects to the link up sheet, and off you go. Now, why use alt with the real plant configuration, real 30-day average and 24-hour? Well, the main benefit of IViewOps, and where it differentiates itself from other just design models, is that IViewOps is intended to simulate actual day-to-day conditions when you have tanks in and out of service, pumps in and out of service, one of 3 blowers out of service, etc., or a clarifier out of service, actual conditions, which is a much higher standard of accuracy and a much deeper sophistication in the math and the math algorithms around IWA, ASM2D enhanced, so that we can simulate not only fast but also far more accurately. And so there has been a lot of investment in the Silicon Valley area of the US in developing better math algorithms than what is standard practice in the field with the other design models that you see. So why? Well, the design models can take 2 hours to solve a dynamic simulation for a day or for 7 days. Well, in IViewOps, we have certain time limits. We have to solve it fast. Plus, if you use IViewOps as an optimizer to give you better set points, we need the speed. In addition to the speed, we need the accuracy. We are striving for an accuracy where you can even detect problems with your sensors losing calibration, like we are doing at some of the plants we're working with. So, higher speed, higher accuracy, much more sophisticated algorithms. That's the core of where it differentiates itself from others. Now, if you're working with real plants, IViewOps has to talk to data in the plants. The data from the plants may be tanks in and out of service, it may be the flow rates, it may be the airflow rate, it may be the DO set point, etc. Or it could be a stream of data from a sensor, and you want to check the results of IViewOps against the sensor. And quite often people are using it to figure out when the sensor has lost calibration rather than the other way around. IViewOps calibrates itself to lab data, which is a much higher QA/QC. And then, therefore, you can use IViewOps to fill in either gaps where you do not have a sensor, or you correct the sensor data. And that's more in IViewOps 3, which is not covered here. So data protocols. So let's go back here. We talked about the alt sheet. We talked about the 30-day average, where we said you can enter values in here. You can start with a minimal set of values, and we talked about the last 24 hours. But what if you do not want to enter this data every day? Well, you have two alternatives. One of them is almost all plants, big and small, have these what we call daily and monthly sheets. So here is a plant example where there are 12 sheets, but what we like to use is 13 sheets, including December of the last year, from which we develop the 30-day average for every day. It's a running average, and the current day's flows, and all the data goes in for whichever date you want. Here we set it up to a year back just to be able to demo it. That means 365 days before, and one more day because IVops is always looking at the previous day up to today. So we looked at that, and we brought the results in. Actually, I just updated the sheet. It is bringing in values right now for the 11th of February 2014. This video is being recorded on the 12th of February 2015. But what I have done is I have forced IVops to go back and look a day before because I'm using an older file. What it is bringing is the 30-day average of the final effluent, RAS, and WAS, which IVops needs, and then the last 24 hours value of flow, RAS, WAS. You can see the current WAS is different from the 30-day average, and the DO set points, the temperature of the mixed liquor, and the SVI, 7-day running average of the SVI. Now, the plant updates these sheets every day. So as long as you update the sheet, let's say at 10 in the morning, and IVops is on auto run to import at noon, it will pick up the latest 24-hour value automatically from the sheet, and you do not have to do anything other than what you were doing routinely, just keep updating the sheet. Now, we do have protocols if for some reason your operator is ill and you do not update the sheet, then IVops does not revert to some crazy number. It defaults to certain intelligent numbers, which is part of the IP around how we handle not only just flows but set points, etc. Like what happens if a DO probe, which we are looking at, is not in the basin but up in the air and giving you a high DO reading, or a value called NAN. How do we handle that? Well, we have code which filters out those and allows IVops to still operate. So what we have covered up to now is 3 ways of data. One is just go to this, what we call this alt sheet, and just feed in data here as if you were doing a design or a plant evaluation where you're not trying to hook up to the real plant condition today and just using it. Or you can get this file from the plant. Like let's say you're a design engineer and you have been hired to look at a retrofit of a plant. Well, wouldn't it be beneficial to get this real file and the real plant configuration and the real conditions of the pumps and all, and then do your analysis of alt where you're leveraging the current conditions. So that's how this is set up, that we do leverage the current conditions, the current configuration, the current aged condition of the equipment, and we run IVops. Which again, when you get to age condition of equipment, it is a much more intelligent management of assets and processes, which is the key and one of the core IPs around IVops, that you look at assets and processes in combination. Because there isn't one plant out there in the world whose blower today, if it is 5 years old or 10 years old, is the same as the theoretical design blower capacity that the design engineer used. One of the blowers will have aged and it'll be different. So getting to real conditions and doing a retrofit from real conditions is very important if you want the design to reflect real conditions. Now, the third protocol we use is a third-party software, in this case Excel Reporter, which is extracting data from the SCADA database and providing it to a file which IVops reads. So this is the last 24 hours data on any day, and then this one is the last 30 days. This is being used at the Westminster plant. And if you want to look at the Westminster configuration, here is the Westminster configuration. If you look at the files that it is attached to, yes, it is attached to two SCADA files over here, or two files generated off SCADA, and it's bringing that. This last one is bringing in tank and equipment status. So that's another way of doing it. And then there is if you would like, you don't have to use Excel Reporter. There is another plan, the USO plan, which is using Pi, which they have, which also extracts the data from SCADA and gives the 30-day conditions and the last 24-hour conditions. So, in summary, as an operator, if you're an operator, you really do not have to go in and enter the values every day. You can set it up to get the data from your monthly and daily sheets automatically and have IVops read it and go on an auto import and auto run. You can also work with your SCADA and engineering team and the IVops team to have a software extract data from the SCADA database like I showed on the Westminster plan. So life is, people tend to think that it'll be difficult, but really once it is set up, it is far easier to use, and gradually over time we're making it much easier for the operator to just use the parts of the model that they need to use. And continuing that philosophy, the technology is going to evolve. This is IVops 3, which I had briefly mentioned, and IVops 3 is meant to be more friendly to use for the operators. It requires more effort to set up, but once set up, you can have different views. For example, for each scenario, we can have a view for headworks. You can focus on headworks and you can set up which ones you want to monitor. You can focus on solids handling if you would like to monitor the solids handling. Now this screen has a different resolution, but you could, if you had the full resolution here, you would see the solids handling over here. Let's see some other views. Maybe it'll show up on this. You can see the clarifier section. You can move things around a little bit, so based on how your screen resolution is. But for IVops 3, we always recommend going with HD resolution, which is 1920 by 1080p resolution. But you can see the clarifier view. You can see the part of the liquid treatment system, if you wish to, and have its view, which gives you probe data, which gives you profiles, etc., for that part of the plant. Again, if you have the resolution set up correctly, you can see a lot more than what I can show you on this computer, which has a slightly lower resolution. So that kind of ends this video. It talks about how we are doing the communications of data between your lab system. You can have lab data feed into an Excel file and bring it in. You can have your dailies and monthlies feed data in. You can have your SCADA database feed data in. We will, in a subsequent video, talk about how IVops can write to different systems and write to different databases. For example, you would want to know your redundancy before and after optimization, and you may want to pick that up in your asset management database or your CMMS database. So you provide those pieces of information to those databases.